Good morning. My name is Amanda, and I'm from São Paulo, Brazil. In my lifetime, through better genetics and agronomy, my home state has seen a huge increase in productivity on farms. We have gone from quite low yields to yields like those in the most productive regions of the United States. I want to see the same thing happen in other parts of the world, in particular with a crop that originated in Brazil, cassava. Cassava is a tropical crop that produces large tuberous roots with a high concentration of starch. Here in the United States, you have probably eaten cassava as the bubbles of a bubble tea or a tapioca pudding. Or if you are on a gluten-free diet, then cassava is most likely the source of starch on your food. I personally prefer my cassava deep fried. However, in other parts of the world, cassava is a staple. This is especially true for sub-Saharan Africa, where about 500 million people depend on cassava as their main food source. For smallholder farmers who depend on tiny plots of land to feed and support their families, cassava is a backup crop when other crops fail. Especially for women who represent a majority of smallholder farmers, cassava is a savings account. It's a resource they can harvest all year to pay for things like medical treatment and their children's school fees. Despite cassava's importance, however, research and development has been neglected. As a result, cassava yields have not significantly risen in Africa. In Nigeria, which grows more cassava than any other country, current yields are the same as in 1960s. The population of sub-Saharan Africa is predicted to increase by 2 times in the next 30 years. According to current projections, this means either an escalation of a food shortage that's already critical, or a huge increase in prices. History tells us that such situations, besides leading to hunger, result in civil conflict and mass migration. On top of population growth, we have the climate crisis, which is predicted to be particularly severe in this area. This means that we need to produce at least double the amount of food to feed all these people. But the problem is that any new variety we develop, it takes at least 15 years to get from the lab to farmers. We need to increase cassava yields today. As a scientist, this is the kind of challenge I wanted to address. One that once solved can change the world for the better. And that's why, despite the very critical situation, I and many colleagues around the globe wake up every day and work hard. Because we are confident that we can find technological solutions, as we did with the Green Revolution that spared the world from starvation in the last century. So, how to increase cassava yields? A big part of the progress towards the next Green Revolution will also come from breeding and genetic improvements. I am working on the RIPE project to improve the process of photosynthesis. Photosynthesis has more than 170 steps, but simply put, is the process by which plants use carbon dioxide, sunlight, and water to produce sugars. The plant then uses these sugars to grow. Photosynthesis is the source, directly or indirectly, of all our food. However, even in our most developed crops, photosynthetic efficiency is less than 1/3 of its potential. I want to close this gap in cassava. But which of the more than 170 steps of photosynthesis needs improvement? To find out, we use computational modeling to identify possible bottlenecks. We also collect data using equipment like this. We place a leaf inside this chamber where we can control light, carbon dioxide, temperature, and relative humidity. Inside the head of this machine, that are sensors that measures all these variables. Software then read those measurements and tell us how much photosynthesis is occurring in the leaf and how much water it's using. Our models and data from this machine allow us to determine the limitations and effective ways to improve photosynthesis for higher yields with less water. The very good news is that we already know that at least 3 of the processes we have identified as bottlenecks can increase productivity up to 40% in tobacco. Tobacco, of course, sounds like a strange choice. But we use tobacco as a test bed because it's easier to change genetically and it produces thousands of seeds per plant, allowing us to quickly find out if a change results in more productivity. If it does, then we start translating the genetic improvement to cassava. Our work has given us good evidence that in a few years we are going to have much more productive cassava that will thrive even in the climate crisis. This means that smallholder farmers in sub-Saharan Africa, especially women, will produce more food per acre. They will also have a better chance at reaping surpluses that they can sell to pay for things their families need, especially the fees to keep their children in school. But having a cassava plant that produces more, it's not the entire solution. The science is only one piece of a huge system. This system includes scientists, but also policymakers, politicians, lawyers, crop breeders, seed suppliers, and others, including influencers like you. We are privileged. We have so much knowledge we can use to help those in the most need. We can utilize the power of innovation to guarantee that food will be available to make life better for everyone. Thank you.